Welcome to the Stormsurf video surf forecast for the week starting Sunday, December 3rd. Looking at significant wave heights for the North Pacific Ocean, we see a gale developing in the western Gulf of Alaska, heading northeast with seas in the 31, 32-foot range. Looking pretty good for the Pacific Northwest. Also, a gale developing near the dateline with 24-foot seas aimed southeast, offering opportunity for Hawaii. And there's a lot more behind that. Let's get into the details. As usual, start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their tracks. We're looking for a trough that is a dip in the jet, just like that right there. That dip helps support a counterclockwise flow aloft and down at the surface, and that, of course, is the hallmark of low pressure. Low pressure generates winds, winds generate seas, seas when they radiate away from the fetch area produce swell, swell when it hits your beach produces surf. So we have a good, in fact, a great looking jet stream flow, finally. Winds pushing off of Japan up to 190 knots. The jet stream is consolidated. It's not split. Most of this season it's been split back here around 160 each. It's not even making it to the dateline. Now it's pushing over the dateline to a point almost north of Hawaii. We'll say roughly right around 165 west. You see the northern branch starts pushing up north, then falling south. And the southern branch splits, pushes over Hawaii, and then merges again over central California. But it is this area back in here, and this energy right in here, that would feed a developing gale. That downward southeast push helps generate the counterclockwise flow we are talking about, and that builds all the fetch in the southwest quadrant of the storm, and that is the most powerful part of any winter storm in the Pacific. Anyway, let's move forward. As you see, the jet only continues to build in coverage, losing, it's still got 190 knot winds, feeding into that trough into Monday, and then even more so into we'll say late Monday night, early Tuesday, 190 knot winds pushing down into the trough, but notice the trough is starting to get pinched off. That's not so good. You want a broader trough. You get a better opportunity for a counterclockwise circulation to develop both aloft and down at the surface. But still, any trough is good, supported by 160 knot plus winds. The trough holds into Wednesday, still pinched off. Another pulse. Look at this, 200 knot winds pushing into the trough. Very powerful indeed. Again, wish there was just a little bit more gap there, but still, we'll take what we can get. Still, the beat moves on. We get into Friday. Another batch of wind energy appears to be building. There is a more robust-looking trough, a little bit more distance between the two sides of the trough, being fed by 190 knot winds. We're into Friday night, into Saturday. The trough starts to pinch again. More wind energy builds off Japan come Saturday night. 100, 200 knot winds, and then we get into 180 hours out, and that is a broad trough indeed. Split point for the jet, somewhere right around 145 west, so slowly working its way towards the U.S. West Coast. The split jet here typically supports high pressure, and you can see this. British Columbia, U.S. West Coast, probably would be locked down by high pressure, no precipitation at all. But what that also means is maybe light offshore winds, great conditions here, all the storm activity on the dateline moving into the western Gulf, but not proceeding any further. That gives whatever swell that develops time to unwrap, unfold. Hawaii a little bit close to the action here, only 600 to 900 nautical miles south of where all the storm energy will be. California a little bit further away, and the Pacific Northwest some more time for whatever swell develops to groom. Let's go take a look down at the surface. So here we go, surface level pressure, surface level winds, one gale, what is that, about a 972, maybe 968 millibar right now in the northwestern Gulf of Alaska. Small patch of 45 knot winds we saw. I think there was 30-foot seas or so being generated there. A far broader area, weak low pressure in the Bering Sea, high pressure south of that, gradient between the two, compresses the isobars. That in turn generates wind, 35 knot winds over a broad area. We'll just put this into motion. We see the gale in the Gulf, Still 45-knot winds into Monday, but they're starting to push to the north. Most of this fetch is targeting the Pacific Northwest and points northward. The fetch in the other gale, 35 knots, aimed pretty well at Hawaii, but starting to fade out. And as you get into Monday, that whole situation falls apart. But we know we have a developing, steep, but powerful trough in this area. Small gale tries to develop Tuesday in the western Gulf of Alaska. 45-knot winds, very tiny system. Secondary fetch down here north of Hawaii or northwest of Hawaii at 40 knots. The two of those together will generate seas. You can see high pressure over the U.S. West Coast. Impenetrable blockade right there. That's the dividing line right there between stormy weather off on this side of the entire Pacific Ocean and then a calm offshore flow. You can see it right here on the chart for the U.S. West Coast. Hawaii, just to the south of all the energy. Anyway, we continue into Wednesday, Thursday, some sort of gale activity, pretty much fading out. Whatever the fetch is there is over in the eastern quadrant, aimed up at Alaska. Another gale starts developing Thursday. Not particularly strong, but now you get the sense of this just large area of low pressure with embedded mini vortices, if you will. Broad area 40-knot fetch on Friday aimed at Hawaii. Other fetch in the 30 to 35-knot range aimed at the U.S. West Coast. Also notice some sort of tropical activity forecast down here. Now, we'll sort of spoil it. Notice low pressure over this whole area here. That is attributable to the developing active phase of the MJO, something very much that we need. And you can just see in the jet stream, remember, all the energy made it to somewhere over in here, and then it split. That coincides well with the active phase of the MJO being south of it. That's what the MJO does, feeds energy up into the jet stream. Jet stream starts roaring until it surpasses or moves east of where the active phase of the MJO is. Then it loses energy, splits, and high pressure takes over. Anyway, so we're into Saturday. Broad gale, very broad in the, let's call it the southern Gulf of Alaska, just north of Hawaii. Broad area 30, 35-knot winds. Another system building over the date line. We'll just roll this out. Nice little storm here comes Saturday night. Almost 50-knot winds off the U.S. West Coast. Another one developing west of the date line. And that just continues into Sunday. We'll set this up. Look at this. Good storm. 55-knot winds forecast on the date line. Well to the south. Well positioned for both Hawaii and the U.S. West Coast. The other gale starting to fade. This is actually one giant complex gale with an embedded storm and an embedded gale in it. And we'll just roll it out to 180 hours. That's a beautiful looking setup right there. 50-knot winds aimed midway between Hawaii and the U.S. West Coast. If this were to materialize, certainly some sort of swell would develop, but we're 180 hours out. We don't believe any model more than about 4 days out. So this is a rough guideline at best, certainly subject to significant change. Also tropical system down here. Don't take any of this too seriously, but it is something to watch. Look at the models and then see how this evolves. You'll learn something about the nature of the models if you do that. Next up, let's take a look at the effect of those winds on the ocean surface. As we know, there's a gale here, developing 30-knot winds. 30-foot seas, aimed mainly to the east, let's say the Pacific Northwest, but directional spreading to get swelled down into, we'll say, Point Conception. Most energy, though, up into British Columbia, Pacific Northwest. Secondary fetch with, was that 2022, 24-foot seas aimed somewhat at Hawaii. Put this in motion. That fetch builds to nearly seas building 26 feet, aim more directly at Hawaii come early Monday morning. And 34-foot, their max seas, 34.8 to be exact, in the northwestern Gulf of Alaska, aimed at this point more at the Canadian coast than California. Anyway, and that fades out. Wind to Monday. Both these fetches start dissipating. New system develops, 30-foot seas in the western Gulf of Alaska. Very tiny little system. Secondary fetch building with 2022, 24-foot seas. This guy has 26-foot seas. So, certainly energy developing, not super cohesive, not super strong, but certainly worthy of 13, 14-second period swell for Hawaii into the U.S. West Coast. if it all materialized. That fades out. Another system developing on the dateline come Thursday night, early Friday, and still more little bit spurious pieces of fetch building 24, 26-foot seas. That continues. Now we have by Friday night a good solid area of 27-foot seas, we'll say, aimed at Hawaii and the U.S. West Coast, growing in size. Look at this, is a broad area fetch, very close to Hawaii, with solid, we'll say, 25-foot plus seas, U.S., but this is by Saturday night. Certainly solid swell heading towards Hawaii and the U.S. West Coast if it were to materialize. Our next system developing west of the dateline. By Sunday, this continues. Look at this. We'll actually go back a frame there. That's good 26-foot seas aimed at the U.S. West Coast. And then building, we'll just get right to the meat of it right there, with 49-foot seas aimed midway between Hawaii, the U.S. West Coast, and preceding swell ahead of that. Whatever fetches here is, as it moves east, is going to get plenty of traction on an already roughed up ocean surface in here. The ocean very agitated, primed for swell development, and we know the jet stream at 180 hours out is just going to be pumping in this area. So odds for storm development continue very high. Odds for surf, very good. This is something well needed, well deserved, if you will. So take care of your business now, because starting probably sometime late next weekend, or about a week out, let's say, if all this is true, things are going to start getting very interesting indeed for surf spots in the Northern Hemisphere. A quick look at local conditions. We're looking at California. High pressure just off the coast right now, 18Z on Sunday. And a little bit of a cutoff low here northeast of Hawaii, but basically pretty strong, brisk trades from the northeast pushing into the Hawaiian Islands. North winds along the California coast. But come Monday, the high is supposed to start moving inland. Remember, clockwise flow around high pressure. That pretty much sets up offshore flow for California. The short of it, that is to be the name of the game for the entire next 7 days in California. Classic La Niña setup. High pressure locked over the coast, offshore winds, bulletproof, blue skies, while all the storm activity is off to the west. Long-distance swell at some point starts radiating into the coast. You have groomed offshore conditions and swell. Couldn't be better for California. That's the best scenario for a La Niña setup. Part two of that is with the MJO in play, that will continue to feed the jet stream and feed the pattern for the next several weeks. Hawaii, maybe not quite as lucky, depending on how close the storm fronts get to the islands. We'll just sort of put this in motion. You don't even have to look at California. You can see there is the brick wall between high pressure and low pressure. Dividing line right there. What is that? That's about, there we go, 145, let's say, or 140, something along those lines. Okay, anyway, rolling this out. You can see Hawaii onslaught, north winds coming Tuesday. Not looking good. Clocking around northeast by Wednesday. That's quick. Another swell situation, but then northwest winds, it looks like, behind that. And just this dividing line where how far the fronts come south, it appears that they will be having. There's another one. Look at that. Look at a giant amount of fetch moving very close to Hawaii. But what is that? Southwest winds? Maybe select breaks to get good swell and an offshore flow. There you go. Broad, giant fetch, very close to the islands, and actually not too bad relative to California. And pretty far south, Southern California might be able to get some of this action. And you can see this is a pretty good, progressive, strong storm pattern. Here comes the next one. They just can be cycling right in and then bouncing off this high pressure area, radiating north up into Alaska. So let's talk out what's going on a week from now and beyond. Of course, we know the MJO is in a favorable configuration, and what's going on with La Niña and the ENSO cycle. As usual, we start this portion of the tour out. We always examine winds on the equator, specifically in the Kelvin wave generation area. West Pacific here, East Pacific here, date line right down here. This is only 10 degrees north and south on the equator. And the main area we're interested in is just 5 degrees north and south of the equator, from about 135 east to about 170 west, right in here. This is what we call the Kelvin wave generation area. When the active phase of the MJO moves through this portion of the active phase of the MJO moves on the equator from west to east in an active state for 3 to 4 weeks, then in an inactive state for 3 to 4 weeks. A cycle going across the Pacific. Actually goes the whole way around the world, but you get the general idea. The Pacific is all we care about. When the active phase moves into the western Pacific, it caused trades winds to die, or if not die, sometimes even reverse direction. That in turn feeds moisture and heat energy up into the upper atmosphere, and that in turn feeds the jet stream, and we've talked about what happens after that. Storm production increases, and likewise in the inactive phase it decreases because there's the energy source, the heat energy source to the upper atmosphere is cut off. Anyway, this from the TAO buoy array, string of buoys strung across the equator, measures actual wind speeds. This is the 5-day average. East trades, the longer the arrows, the higher, the stronger the winds. Looks like pretty strong easterly trades over the east equatorial Pacific. But notice this one little westerly barb here, and some of the sensors are out of here, so we don't have a good picture of what's going on. Anomalies, though, the bottom half of the chart. What differences from normal for this time of year? Pretty normal in the far east Pacific, but far stronger than normal easterly trades here over the dateline region. So the Kelvin wave generation area goes right to about here. So we could say there's easterly anomalies in the eastern part of the Kelvin wave generation area, but westerly anomalies in the western portion of the Kelvin wave generation area. The dividing line right around 160 or so. And that's about midpoint through the Kelvin wave generation area. So half of it's being affected right now by the active phase of the MJO, the other half by the outgoing inactive phase of the MJO. Both are moving off to the east, or at least should be theoretically. Here's another way to look at what's been going on for the past several weeks. The date line is, I think it's right here. This is the whole world on one planet, going west that way, going east that way. The date line, of course, generally in the West Pacific, a little bit off to the west from Hawaii. And you see the blues. This is only the east-west component of the wind. You can see steady easterly anomalies on the date line and into the Kelvin wave generation the whole month of November. That is attributable to La Niña. That's what La Niña does. But notice here, somewhere, now this isn't even in the Pacific yet. This is maybe over maritime continent, maybe making it out to the Philippines. We'll go down. There you go. You can see. So 135 east is about right here. So you can see westerly anomalies starting to build, but very strong, very, very strong easterly anomalies off to about 165 east. And that's supposed to hold for the next, this is a GFS forecast for 1 week, hold for the next week, suggesting the active phase of the MJO making a major push east. Sure wish we could get it to totally fill the Kelvin wave generation area. But you can see, we saw what the wind models look like. We saw what the wave models look like. Even with the active phase of the MJO just filling half the Kelvin wave generation area, boom, instantly the jet stream wakes up, the storm cycle wakes up, and if all this plays out the way it's forecast, a much more active swell pattern is expected. Here's another MJO model. This is outgoing long wave radiation. So the MJO in the active phase, it's like a big low pressure system, okay? And here's the West Pacific, East Pacific. There's Peru, Mexico right there, Philippines, Guam right there, equator running right across here. And there's your date line right there. And you can see, there's the reds are the inactive phase of the MJO. This is the cloud component of the MJO, meaning high pressure, meaning less clouds, meaning easterly anomalies. The blue represents negative anomalies. That means more cloud cover, less sunlight reflectivity off the ocean surface. That means low pressure. That means the active phase of the MJO and storm production. The dividing line, just about on the date line, a little bit east of the date line. Anyway, you can see the forecast for the next 2 weeks. This is 15 days. The inactive phase fades, drifts off to the east. The active phase holds on and pushes to the west. This per the statistical model, the CA model they call it. The dynamic model predicts almost exactly the same thing. Both models in good agreement. That is a good sign. This is phase diagram charts. Another way to look at the forecast. Assume the circle you're looking down on the North Pole. The active phase, and the inactive phase for that matter, travel west to east around the globe from Indian Ocean over the maritime continent, consider that Bali, over the dateline into the West Pacific, across the Pacific under the United States, across the Atlantic on the equator, across the northern part of Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is. If it's inside the circle, it's very weak. If it's out here on the periphery, it's considered extremely strong. This is a moderately strong active phase of the MJO in control in the extreme West Pacific right now. The forecast for the next 15 days, next 14 days, 2 weeks, has it moving from further into the West Pacific, but weakening some. That per the ECMF model. The GEFS model has it holding strength, doing pretty much the same thing. Again, good agreement in the models. A super long run model, 40-day upper level view. This is just based on precipitation or potential for precipitation. Right now, you see greens. That means good chance for precipitation. That is a proxy for the active phase of the MJO, and you can see it literally moving off to the east through about Christmas time, December 23rd. At that time, the inactive phase of the MJO makes its appearance in the West Pacific. It, too, moves off to the east and is almost out of the picture come mid-January. And at that time, the next active phase of the MJO starts making its appearance in the West Pacific. Again, about 3 weeks to make the transition from here, what do we say? What's this? December 3rd to here, December 23rd. That's about 3 weeks, and you could go each of these phases. I mean, it varies. It's not always like clockwork. Sometimes it's 3 weeks, sometimes it's 4 weeks, sometimes it's different. But the general sense, 3 weeks active, 3 weeks inactive, then here you go, your next 3-week active period. And what you wait for is the active periods, because when those happen, first off, you get swell production in the West Pacific. It slowly starts moving its way east, and then as the active phase starts moving into Central America, that's when you start getting rain, precipitation into California, storm, snow, and what was a good groomed swell pattern for the eastern half of the Pacific gets kind of chunky and nasty. And then yet an even longer lead model goes out about, 3 months? This is the CFS model, 850 millibar wind anomalies. So the dateline runs right or down. Let's see if we can actually get this. There you go. There you see it in the picture. Pretty much right up through the middle of the chart here. In fact, here's where we are today. You can see it. The blues are easterly anomalies. The yellows are westerly anomalies. Now, past instances is here. The future is up this part of the chart. You can see the last active phase of the MJO right here, where we had westerly anomalies in the Kelvin wave generation area, was late October, November. We had a 3 or 4 week run of swell right then. Kind of looks like that's getting ready to set up again. Now, the neat thing about this model is we can do this and actually overlay the MJO. The dotted line is the inactive phase of the MJO. That's what's in control, but it's losing ground quickly. Active phase of the MJO here scheduled starting in the West Pacific, in the next 5 or 6 days or so, and holding in some capacity probably till about Christmas time or so. Here's the inactive phase of the MJO. Pretty strong forecast after that, holding into about January 12th or so. That's in pretty good agreement with what we saw in the other models. And then, again, this phantom massive active phase of the MJO, the model's been showing this, it comes and goes. It's always, there's a big active phase, a month out on this model or so, and it's going to last for 2 months. Never quite plays out that way. But anyway, nice big tease. Now, the other thing here is the dateline runs right down about here, and that seems to be the holding dividing line between west anomalies and east anomalies, unless you get this inactive phase where it all turns to east anomalies, but we'll see. Now, we do the low pass overlay on top of that, and this shows you this solid contour is the bias towards low pressure, which you can kind of roughly correlate to sort of a bias towards a El Niño signal. Of course, it's all bottled up mainly over the Indian Ocean, and over the Pacific Ocean right here, you have this dotted contour. That is the high pressure bias, but you notice it's sort of sliding off to the east, and the low pressure bias is trying to make its way the same direction. Let's see, where's the date line again? Let's see if we can get that in here, right there. Okay, so there's the date line. You see that as we get into right about there, end of January or so, roughly, the date line's right in here. At least half the Kelvin wave generation area, if not more, will be under the influence of this low pressure bias, and less of it will be under the bias of the high pressure contours here. So that generally supports, as we get deeper into winter, a stronger storm pattern in the West Pacific. And one last MJO signal here. This is the chart, strength of the active phase of the MJO. It doesn't say where it is, just says it depicts the general strength. During the El Nino year 2015, January, big spikes in the active phase of the MJO, not unexpected, even into January 2016. And then another push last year in the March timeframe, somewhat supported the precipitation anomalies in California in that time frame. But then, as we got into late March, early April, you notice the MJO just died. Absolutely nothing. Then we had our one pulse back in October, and now it looks like we're getting ready to start our next active phase pulse. We expect this to go on for a couple of weeks, probably into late December. So right in there, we're hoping 3 weeks from now, you'll see a big, well-developed spike right off in here. This is sort of an after-the-fact, hindcast look at what's going on. But you definitely get the sense that the active phase of the MJO is building, and it's not just going to be a wimpy little thing. It'll be a pretty robust event. So we've talked about the MJO. Let's go talk about what's going on in the ocean at depth. West Pacific here, East Pacific here. These are the anchor lines off the TAO buoy array. Buoys strung the entire way across the Pacific on the equator. Not only do they measure surface winds, we looked at some charts on that, they also have sensors strung down the anchor lines so you can measure temperature and then use a model to sort of connect all the dots and figure out what's going on. Warm water in the west, much less warm water in the east, a very shallow warm water profile in the east. That's pretty consistent with La Niña during El Nino. This warm water here sloshes off to the east. The balls of, or pockets of warm water that push off from west to east are known as Kelvin waves. They originate in the far west Pacific from changes in the trade winds there. That's why we call this area over here the Kelvin wave generation area. Anyway, looking at anomalies, differences from normal for this time of year, you can see it pretty plainly. Warm water, 2 degrees above normal at depth in the far west Pacific. Where's the date line? Right there. Okay. Cool water in the east. That is a classic signal of La Niña. We don't expect that to change anytime much this winter. Another modeled version of that, just a different model, same raw data, suggests 1, 2, 3, 4, 1, 2, 3, 4. Warm water to maybe 3.5 degrees in one little pocket, but for the most part confined to the far west Pacific. Lots of cool water at depth in the East Pacific, and upwelling being drawn up to the surface. Remember, hard trades are blowing here, pushing all warm water that would be in the West Pacific or that is warmed by the sun off to the west. I'm sorry, in the East Pacific, pushing it to the West Pacific, allowing this cool pool then to be sucked up to the surface, creating what is likely a large cool surface pool in the East Pacific on the equator, and that is the classic hallmark of La Niña. And here's another way to look at it. Upper ocean heat anomalies, upper 300 meters of the ocean. These yellows, oranges, reds are warmer than normal water. Were last year, February, actually 2 Kelvin waves, small Kelvin waves, one here in March, one in the May time frame. Actually created almost like a mini El Nino, but it was very late in the season off the Ecuadorian coast. That quickly faded. And then we were back into, by August, this cool pool development in the East Pacific. There's your warm water in the west. Dividing line right around 170 or so according to this classic La Niña signal. Also a good hint of what's going on subsurface. You use JSON-2 satellite data, strip out all the winds, strip out all the tides, strip out anything, and you see that there's kind of a divot, a 10-centimeter divot here on the equator. That's South America there. There's Ecuador there, Mexico. You get the idea. Japan up here. Anyway, this area right here, 10 centimeters below normal. There's actually a little break here. That's new. It was continuous in this area. But what that suggests, cool water at depth. Cool water, of course, contracts a little bit. That's what causes the divot on the surface. Warm water in the West Pacific expands a little bit, causes a bulge, 5-centimeter bulge on the equator. Again, just confirming the La Niña prognosis. Looking at high-res sea surface temperature anomalies, differences from normal this time of year. You see blues. Blues here are negative anomalies, meaning cooler than normal off Peru. continuing on over to a point at least south of Hawaii. No, the difference here is that this is not as cool as it was a week ago, though there seems to be some new cooling, upwelling building along Peru. We'll see. It sort of pulses. It gets cooler, warmer, and that all is tied to the MJO. The trend for the past 7 days, just the past 7 days, yellows. So here's the dividing line, green, reds and oranges, yellows. That is warming. So yeah, temperatures are a little bit warmer off for Peru than what they've been the past 7 days. And actually you're getting some pockets of warming along the equator, interspersed with some cooling pockets, sort of suggests a stable trend. Now this is just talking about the change in the past 7 days. It's not talking about absolute temperatures, but here is the anomalies, differences from normal for this time of year. Clearly you see much cooler water than normal along Peru and Chile. They're not quite as cool as it was a couple of days ago, but or maybe a week ago. But what you also see is the extent of the cool anomalies building in coverage, and you really can't miss this signal here. Very deep cooling from Ecuador out to the dateline. This is a classic La Niña signal. When you have dryness here, when you have cool water here, that means less evaporation. That means less transport of heat energy to the atmosphere, which typically means high pressure north and south of where this is. And remember, the MJO, there's this sort of dividing line going on right here on the date line. East anomalies here, west anomalies here. You can see the thermodynamic support of why that's occurring. You're cold here, you have high pressure, you have blocking high pressure off the U.S. West Coast, but you're warm here, you have jet stream support, you get storm pushing maybe a little bit over the magic line, but at some point it fades and dissipates. So this is a classic La Niña signature. Likewise, if you had El Nino, this would all be warmer than normal, and then maybe you'd have cooler temperatures off in here. So complete reversal depending on El Nino or La Niña. And also, notice one thing. We actually weren't too alerted about this until just recently. Warm anomalies between New Zealand and Australia and Tasmania, up to 6 degrees above normal right here. This is also considered a classic sign of La Niña. So what's the effect on the atmosphere? We've looked, we know about what the MJO is doing. We know what's going on in the ocean at depth. We know about what's going on at the ocean at surface. But ultimately, it's what's happening to the atmosphere. And there is a feedback loop. You know, the ocean does its thing. It affects the atmosphere above it. The atmosphere does its thing. It, in turn, affects the atmosphere. And the two of them start working in parallel. So this is a Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. During El Nino, you would have lower pressure over Tahiti, higher pressure over Darwin. Darwin gets locked down by high pressure. They get droughts. They get fires. Australia starts burning. Likewise, the eastern half of the Pacific gets drenched. Now we're in La Niña. The reverse is true. Very warm water off Australia. They get soaked with rainstorms, theoretically. Likewise, things dry out, very dry. U.S. West Coast down into Peru, that sort of thing. Anyway, so when the index is positive, this is the daily index. Today, 21.57. It was up to 30. And then you can see for the whole month it's been positive. That suggests at least the inactive phase of the MJO. If it goes on for a long period of time, that suggests La Niña. The 30-day running average was 9.65 a month ago. It's up to 10.4, so it's continuing to build. Also, the 90-day running average, that takes even more dirt out of this and more noise out of it, up to 9.2. This clearly suggests that La Niña is in control. We all knew that already. No big surprise, but we're just looking at the numbers to confirm it now. And it appears to be building. This will probably go up into the 12, 13, maybe 15 range before it's all said and done. And the ESPI index, the same sort of deal, only instead of measuring pressure north of Darwin, Australia, and north of Tahiti, it measures rainfall anomalies. If it's wetter than normal in this region, and that's where we would have warmer than normal ocean temperatures, that would be El Nino. If it's colder ocean temperatures here and drier than normal, that means La Niña. And you can look here. Here is the actual rainfall anomalies. You can see actual average rainfall for the last 30 days. The anomalies, very dry, bone dry here. That means cold water. And of course, we know that is the case. Wetter here over Australia. That means, of course, warmer water, and we know that to be the case too. The index today is minus 1.61, falling. It was like minus 1 or 0.9 or something like that last week, I believe it was. Getting more negative, meaning drier in this region, meaning La Niña. Oh, and when we showed you the 30-day, the SOI index, the previous set of charts, here's the 30-day running average graphically. So you can just see back in 2015, 2016, El Niño sort of thing. You see the pulses in the MJO. Then we got into July 2016. The SOI went positive, tried to back off a little bit, but now we're back up into the positive range. And when these upward spikes are all the inactive phases of the MJO, downward spikes are the active phase of the MJO. So we're expecting this guy to start shooting downward into December as we get into the deeper into the active phase of the MJO. And also sea surface temperature anomalies for the area. The Niña 1.2 index, that's right off of Peru and Ecuador. You can see the temperature trend has been steadily downward. We got a little bit of a warm spike there in later November, and we're having one right now, but still we're negative. Right now, today's value, minus 3/4 of a degree, basically. That's not particularly good news. If you want storm development into California, you want to see it up in the positive range. We're not going to see that. This is what La Niña does. And the main Niño monitoring region, the Niña 3.4. So this is the whole area from the Galapagos off to almost to the date line, 5 degrees north and south of the equator. This is the official El Niño or La Niña monitoring region. You can see this trend since September. Sea surface temperature steadily downward. We're down basically 1 degree below normal as of December 3rd. And the question is, where is it going from here? Here's the official forecast from the CFS version 2 model. Right in here is where we are today at 3/4 of a degree below normal. And the forecast, the good news is, it was supposed to get down to 1 degree below normal last week. A couple of weeks ago, it was down to almost 1.2 or 1.3 degrees below normal by January. Right now, this suggests we're as cold as we're going to get. Our La Niña has bottomed out. That's actually good. So this is a La Niña, but not an extraordinarily strong La Niña. The interesting thing about the forecast now is, well, even come July, we're still supposed to be a 1/2 degree below normal, which means we're still in La Niña, which means maybe we'll end up in yet a 3rd year of La Niña. Hard to know this far out into the future, but right now we'll call it a moderate La Niña and holding for at least the next 6 months. So the short-term view is the storm track and the jet stream looking much better. Longer term, influenced by the active phase of the MJO, series of storms, or at least gales forecast for the Gulf of Alaska, and over the dateline region, likely making swell, small swell initially, but potentially building as we get later into, we'll say at early next, or a week from now and beyond, the active phase of the MJO, taking a better route, feeding the jet stream, and potentially developing yet more and stronger gales as we get into 2 weeks out or more, getting closer to Christmas. That's very good news. Still, long-term outlook, not so great. We're in La Niña. We knew we were going to be in La Niña this year, and that's the way it's shaping up. The good news from that is it's not horribly bad La Niña. We'll call it a moderate La Niña. We knew we were going to pay the price. We went through El Niño. Now we're in the other side of the cycle. That's the way it goes. Make the best of it. When you can get surf, go get it. Don't miss any good opportunities. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.